Welcome. This is grade 12, and I'm going to do the past question paper of 2019, and this will be paper 2, question 1. So you'll see 2019, paper 2, and question 1. So what they say, I'm just reading from the paper, but I've just written the highlights over here. So P, they say, is the center of the circle ACBD. So P is the center. AB and CD passes through P. So let's first see, where's AB? So here we have AB, and then we have CD. All right. So here's the equation of CD, and here's the equation of AB. So before we look at the question, let's just first see if we can identify a couple of things. So firstly, we already know if we have points on the circle, they'll probably ask for some points. So we see a line AB, the blue line, and it intersects with the line CD. So just keep that in mind. And it looks like P is the center of the intersection of AB and CD. So that is something to keep in mind. So what I'm trying to do before I start with the sum, I'm just looking at my approach. How am I going to approach it before just going into the sum? And I like drawing it over for myself. Then I can redo it with colors, etc. So we have two equations. So that's in the equation form. So let's see what they want. All right. So first they want determine the coordinates of A. So where's A? So here we have A over here. So the coordinates of A, so let's see how we can approach that. So A is a point on AB. So remember, this is a line AB is given, and A is a point on AB. So what I'm going to do here, I'm going to use the equation of AB, this equation over here. And then I'm going to, now if you have the point A, you can already see it lie on the y-axis. So there's the y-axis. So let's just draw the y-axis and the x-axis. So here's the y-axis, and there's the x. So at least you can see. So the point A lies on the y-axis. So already if you do that, you can write that 0 over there. Not the 0, sorry, not there. The 0 is here by the x. So if it lies on the y-axis, then the x is 0. So already we have 1 point. So the approach that I'm going to do here, I'm going to take the equation of AB, and then I'm going to plug that value of 0. I'm going to substitute it where you see a x. And if you see that, then y will remain. So I'm just explaining what I'm trying to do. So if you take this equation, then there's two unknowns. So the one unknown is y, and the other one is x. So if you already have 1 point, and that's why I always write down what I have. So if you have 1 point, then you know one of the two variables you will have, and then the other one will be easy to get. All right, so let's see if we can determine A. So let's just write down that equation again of AB is y equals minus 2x plus 3. Like you saw on the pic, we have the 0 for x. So if we have the 0, we're just going to do normal substitution, where we're going to say where we see the x, we put the 0, and then just continue. So y will equal, that is 0 plus 3. So y will equal 3. So we have this 3, and remember we have the 0 as well. So that will be 0 and 3. So 0 and 3 will be the point of A. So we go back to the sum, then that will be 3. Another thing what I like to do is I just, when I have an answer, which is 3, then I just try to visualize on the on the X and the Y axis, does it make sense? So there's 3, and it kind of looks like 3 can be there. If you would have had the answer here, and this Y would have been -5, and you go back here, so -5 on the Y axis is somewhere here at the bottom, but the picture is showing you on top, then you know it would have been a problem. So after I arrive at the answer, I just look at visually the diagram and just ask myself, does it look right? Does it make sense? And indeed, it does look right. Right. So let's go to the next question. The next question is calculate P. So calculate P. And if we go back, P is the center of the circle. So let's see, we already spoken about this. P is a point that is on both the AB, the blue line, this line over here, and also on the yellow line, CD. So if you have that already, the word simultaneous equation must pop up. Why? Because we have this equation, CD, and we also have the equation AB, the one that we did the whole time, the blue one. So now we know if we have a point that is the intersection between the two lines, then we're going to use simultaneous equations. All right, so that will now be our next step to determine P. So let's just write down the two equations again. Oops, we have AB, which is y equal minus 2x plus 3. And we have CD, which is y equal 3x minus 7. So at this stage, I assume you have looked at my previous videos. There is one of the grades for simultaneous equations. So please look at that, where I go into detail how to do it. You are now in matric, grade 12, so I expect you are much more advanced and know how to do it. So my pace will be a little bit more faster. And as you can see, all the previous work in maths is now coming together in only one question. Right, so simultaneous equations, we already have two equations that equals y. So now I'm just going to put these two equal to each other. I'm going to say 3x minus 7 equals minus 2x plus 3 because both is y. So that's going to give me 3x plus 2x on the left-hand side. On the right-hand side, we're going to have 7 plus 3. That is 5. X is 10. X equal 2. All right, so x equal to 2. So now I have already the x-axis of the P. So let's see if we can have the y. So now I just substitute this back into any one of the two. So here is y equal 3x minus 7. Just put this 2 back. And then, oops. So then it's y equals 3 times 2. So that's this 2 over here. Minus 7. That is 6 minus 7. And that is y equal to minus 1. So now we have P is 2 and P is minus 1. Let's go back to the big sum, 2 and minus 1. So let's just write it down, 2 and minus 1. So let's see, does it look right? So 2 is x. So yeah, okay, that looks like a 2. It's positive, so it looks like 2. And this is also below the x-axis, so it can be minus 1. So the x is 2. So you just basically, it would have been like that. That is minus 1. And if you go up, that would be 2. Excuse me. So that's just how you can, and that a, that would be 3 over there. So that's just how you can visually look at it. So now we have the center point, which is P. Right, so let's look at the next question. The next question is calculate the length of AP. Now, where's AP? Let's go back. So there's AP. You know what? Let's use red. So there's AP. So let's first look at our approach. To do a question, to determine a length, you must ask, what do we need? And on your information sheet, there is an equation, and the equation needs 2 points. So the equation looks like this: D, oops, let's do it with black. D equal big square root x2 minus x1 squared and y2 minus y1 squared. So that is what you have on your information sheet. And we do have the points. So we have AP, we have the point A, which is there, 0 and 3. And we have the point P, which is 2 and minus 1. So let's use that 2 points, 0 and 3 and 2 and minus 1. Let me just write it down here. So A is 0 and 3, and P is 2 and minus 1. So let's just write it there, and then I'm going to use that 2 points in here. So let's write the big square root again. So let's use this one as 0.2 and A as 0.1. So x2 will be the and I'm going to change it around, sorry. Just want to keep it the same as your marking schedule. So x2, so if you just take this, I'm just going to break it down slowly. So if you take this over here, then you have A is 0 and 3, and P is 2 and minus 1. I'm just doing for those that are struggling with this. So if this is 0.2 and this is 0.1, what I'm doing here now, the equation here say x2 and x1. So in this sum, if this is 2, then this is x2 and that is y2. This will be x1 and that will be, oops, y1. So let's see if we can use this and just see if we can get to our answer. So that's x2 and x1, because we've marked that point as 2 and we mark this point as 0.1. That's why this is x1, y1, x2, and y2. So let's see if we plug it into the big formula, what do we get? So just put the x2 minus x1. So that will be 0 minus x1 is 2 all squared, and y2 is 3, and y1, be very careful, it's not 1 and then you close it. So just be very careful there. And I'm mentioning this because if you make a mistake here, then the whole question is wrong. So this here is not minus 1, it's minus. So this is the minus of that. And then you still have the minus 1. So it's everything squared. So there you can see that's the minus of the formula. And then there's a red part, that's the minus 1, which is this minus 1 over here. So just be very careful. You sit now with 3 minus minus 1 and not 3 minus 1. So let's just get rid of this now. So now you have this equation that looks like this. So now it's just a matter of completing it. So you have here in the bracket minus 2 squared, minus 2 squared plus 3 minus minus 1, which is 3 plus 1 squared. And then it's 4. This is minus 2 squared, which is 4, plus inside is 4 squared, that is 16, and all of that equals square root of 20. So square root of 20, that's let's call it the length of AP. So length of AP is square root of 20. So let's just go back to the sum. So this is what they wanted, length of AP. So that length is square root of 20. All right, let's just go back to what we just had now. So again, let me just repeat again. So if they ask for a length, you need 2 points, and we have 2 points from the main graph. So I just made the one point number 2, the other one number 1. And as you saw earlier, I showed you how to make it x2 and x1, y2 and y1. And this is a matter of substituting it into the formula and just completing the sum like this. Again, I just want to highlight this part here is 3 minus minus 1. Because if you would have written 3 minus 1 and make that squared, it would have been 2 squared, would have been 4, which is not the same as 16. So that is just what I want to highlight. Right, let's continue. So that's the length of a P. So what's the next question? Next question is, so now they give this, write down the circle equation with the center P, which is in the form, then they give that form. Now, fortunately, we have P, because if they say they want it with a circle with the center P, we have P, we calculated it earlier. And I just want to highlight, if you calculated the center point incorrectly, then unfortunately the sum we're going to do now will also be incorrect. So that's why just always double check your work, always make sure you understand each and every sum, because they build on top of each other. All right, so we have P, which is 2 and minus 1. So let's just see if we can take this equation x and just put I'm just gonna write here at the top, so that P is 2 and minus 1. So the equation of the circle will now be the x. So P is 2. Sorry. So this P, this is the center of the circle. What I'm going to refer now is this P and this Q over here. So it's that P and that Q. So if you have this equation over here, this P and that Q refers to the center of the circle. And fortunately, we do have the center of the circle. So once you have the center of the circle, you are in a position to work out the formula. So now we use this point P and point Q, and let's put it into the formula. So we have x minus, so I'm going to use this P of 2, which is this P over here. So that I'm going to put there. Let's close it. Squared plus y minus q. Now, just want to show you, I'm going to use this q over here and put it there. But it's not minus 1. Same like the other one, it's now minus 1. Everything in bracket. So that's minus 1. And everything squared equals r squared. So I just wanted to point that out. So let's just write it out neater. So it's x minus 2 squared plus y. But this now becomes y minus 1 becomes y plus 1. All of that squared equals r2. So now we have a formula, but we still need r. Now the question is, how can we get r? So now let's go to the circle and see. We have a formula which is not complete yet, but the question is, do we have a point that is on the circle that we maybe can use? We don't have C, we don't have B, we don't have D, but A is on the circle. So if you look carefully, we have A, which is 0 and 3. So just keep that in mind. Now, if you take that 0 and 3, this is X and this is Y. So I just want to show you again that this is a point on the circle, A, which is 0 and 3. And we have a formula for the circle, but it's not complete yet because here's 3 variables. But the X and the Y, we can leave it, but we need the R. but we don't have r. But what we do have, we have this point x and y, and if you substitute the x in there and the y in there, then you can find r. So fortunately, that is something that we can do. So let's see if we can do that. So I'm going to take the 0 and the 3, and I'm going to substitute it into here. So wherever you see x, put 0. Wherever you see y, you put a 3. And then you're going to have something like that. And if you work everything out, you will get to r squared equals 20. That means r equals square root of 20. So you can just work it out. You'll get that answer, because this will be 2 squared, which will be 4. And this will be 4 squared, which will be 16. So that will give you r squared equals 20. So r equals square root of 20. So now, just want to go separate here. So just to write the formula properly, you'll have the x minus 2 squared plus the y plus 1. And now you can just say all of that will be equal to 20. And that is how you write the formula. Just a reminder again, everything here equals r squared. And if you look here on top also, you have r squared. So at the end of the day, we want to work out what is r squared, and that is going to be in the formula. And this r squared was 20. And that 20 is what we put over there. So this over here will be the final circle's formula, or the final formula of the circle. So let's just recap briefly again. They ask, write down the circle equation with center P in the form, then they give that form. Now this form here means P and Q. PQ is the center of the circle. Fortunately, we have the center, which is P, big P, which is x is 2 and y is minus 1. So what we have done, we've substituted that into here. So the P, we put it in there, and the Q we've put in there. And worked out r squared, and at the end, the r squared was equal to 20, which gave the circle's formula like that. So I just want to highlight, I talked a lot, but this is only worth 2 marks. So I'm explaining in a video in detail, but when you do it on your own and you do different exam questions, speed is extremely important. So speed is important, work through it quickly, but just try to memorize as much as methods as possible and approaches as possible. Right, let's go to the next one. Calculate the coordinates of B. So that's the next one. Calculate the coordinates of B. So where's B? There's B. So what can we say about B? Okay, number 1, B is a point on the circle. And okay, we do have the circle's formula. So keep that in mind. We have the circle's formula. Now they want point B. Calculate the coordinates of B. So let's look at the circle. So here's a formula, but now they want B. Okay, we have an X, we have a Y, but let's just look properly again. There's another thing. B is also a point on AB. So B is a point on AB, and B is also a point in the circle. So it sounds like a simultaneous equation again, because you have a line with this equation over here, AB, and we have the circle over here. So what I'm going to do now, there's a circle's formula, then I have the lines formula, which is the AB, which is minus 2x plus 3, and I'm going to substitute. So this is y equals minus 2x plus 3. So what I'm going to do now is substitute this whole y equals minus 2x plus 3. So this y part I'm going to put into there. just to see where am I going to get up. Why do I do it? Because if you put this y over there, then you're going to sit with only x's. That means you have one variable and you're going to get x equal to something. Because we have a square over here, we'll probably have x equal to two things. But we're going to use this diagram to guide us and assist us where exactly will be. So that is, let's see where we get. So that is my approach, and this is what I want. X equal something or another thing. So and my hope is, so here's again my approach. My hope is to get an answer. So here is 2. This B, if you take that up, it's somewhere there. So if that is 2, this is probably 4 or 5 or somewhere there. We don't know where it's yet, but if this is 2, then that's probably 4 or 5. This is definitely not a minus. This is definitely not 100. So let's hope it's somewhere in that vicinity. So okay, let's go see if we can substitute. Where do we get? So I'm going to take the big formula, x minus 2 squared. And now wherever I see this y, I'm going to put this minus 2x plus 3. Let's just continue with the sum, and it looks like that. So there's the y, which is minus 2x plus 3. So now I'm just going to continue with previous grade's work and just calculate x. So here we have x squared minus 4x plus 4. So I'm just going to keep that in a bracket first. Just going to simplify that. So let's just do the bracket first. That is 4x squared. That is minus 8x, so it's minus 16x plus 16. Okay, so I just did this part now. So just don't forget to write all the other stuff down. X, I'm just going to remove this bracket also. So that's just going to stay x squared minus 4x plus 4. All right, let's just remove those blue lines. You can remove that bracket as well. That's going to become a plus. So that's 5x squared minus 20x. Looks like plus 20 equals 20. You just continue. So this 20, if this goes over, it's going to be 0. So now it's just going to be 5x squared minus 20x equal to 0. So let's just do it maybe on top. Maybe here's some space over here. So the next step is going to be 5x squared minus 20x equals 0. And if you do the substitution, not substitution, factorization, then you'll get something like that. X equals 0, or 5x minus 20 equals 0, then you'll have x equal to 4. If you work that out, you'll get x equal to 0 and x equal to 4. Sorry, my space is running out. That's 5x minus 20 equals 0, and then x equal 4. This is just previous grade's work. That's why I'm just going much faster through this. Okay, so what does it mean? We have an x equals 0 and an x equals 4. So let's just look at the sum. So remember I said I wanted somewhere with a 4 or 5. So indeed there is a 4. So 0 is over there. That is definitely not 0. So that's definitely 4. So B has got the x coordinate of 4. We don't know the y coordinate yet, but at least we know the x coordinate of 4 is definitely not 0, because 0 would have been somewhere this side, and B is not there. Right, so we have the B, which is a coordinate of 4. And now, if you go to the same sum, I'm going to use this y, the AB's formula, which is y equals minus 2x plus 3. So y equals minus 2x plus 3. We already have x equals 4, and now we can determine y, which will be minus 5. So why did I do that? Let me just go back again. So just keep in mind, we calculated the two values. This is still simultaneous equation. So we did a lot of stuff, but just keep in mind, we're still busy. There's the one formula, there's the other formula. So this is still part of simultaneous equations. So I worked out the one part, which was x equals 0 or x equals 4. We decided on x equals 4. And now that x equal to 4, I'm now going to put back into this formula to find y. You can do it in the big formula, but that's just too big. So I'm going to put it in the line formula to find y. And that y will then be this y over here. All right, so let's just continue. And there's, sorry, I'm finished. Y equals minus 5. So that minus 5 is the minus 5 of the b. So we can take that out and we can now make that minus 5. Let's just check, does it look right? So the minus 5 is on the y-axis. It will be this way. It does indeed look like a minus 5. Like I said, I always check it. If that would have been 3, 3 would have been on the y-axis somewhere on top, or 2 would have been on top, then I know something is wrong. But now I know that's minus 5, so it does look right. Right, so there we have the point for P as well. Still the same question. Can remember in the previous grades, I can do a 30-minute video and fit in probably 10 or 15 questions of one thing in a 30-minute video. And now at matric, we're still with question 1, and it's taking me almost the same amount of time. But I have to explain in detail just so that you can understand it. Right, I think there's one more question left. So the last question is saying, I'm just going to this. I'm just going to take this out here, the minus 20. I'm just going to clean up this a bit. Okay, so it's going to look like that. They just take that 2 out and all of this. So question is, they say Q is an x-intercept of AB. So remember, AB is the blue line and Q is the x-intercept. So what is the x-intercept? So the x-intercept will be somewhere there. So it looks like that is Q, is the x-intercept of this blue line AB. Now ready, x-intercept, before you continue, they want, they want that already, the x-intercept mean y will equal 0. So we need the x, but we already know y equals 0. But they want the equation of the line that is parallel to CD and passing through Q. That's a lot of words. So they want, so there's a point, Q, but they want this line that is parallel to CD. So remember, CD is this yellow line. But now they want a line that is parallel to CD and passing through Q. I'm just spending some time with this so you can understand what we're busy with. So there I drew the thick red line now, and that is definitely parallel to CD. And remember, parallel means the distance is the same from each other. So that's two parallel lines, or it can look like that. So that is what they want. So they want the equation of this line passing through Q, which is parallel to this yellow line CD. So what is our approach? So how I'm going to approach this is, we have the CD. We have CD. Here's CD, the yellow. And if they want an equation of a line, we're going to end with y equal mx plus c. So let's work with that and see what we have. So let's first talk about it. We have the yellow line, but any line that is parallel to a line has got the same gradient. What does it mean? What is the gradient of CD the gradient of CD is that 3 over there. So that means the red line, the one we want, will have the same gradient. So this is the one where we work towards. So that is the same gradient. So we can already say y equals 3x plus c. So that is what we already one step further. We don't have the y-intercept yet, but what else can we do? So let's just think about it. We have that 0. So that 0 we can put in there. We don't have a y yet, but we do have this blue line AB. So let's just write the equation of the blue line, and remember that is y equals minus 2x plus 3. So we have y equals minus 2x plus 3. And why I'm writing that down is because Q is also on the blue line. So if we have Q and we have this, the 1 point is 0. And if we have the 1 point is 0, the X, and I'm actually going to put, let me just double check again. No, the X is not 0. The Y is 0. So if you have this, the Y is 0 and the X we have to work out. So the Y is 0 and the X we have to work out. So if you go to this, the Y is 0 and we have to work out the X, you're going to have something like this. So now let's work out the X, which is 3 over 2. So that means that X, which is 3 over 2, that is this X over here, which is, so you're going to look 3 over 2, comma 0. So I just want to say again, the 3 over 2 is the X and the Y, that is the 0. So now we have the point Q, 3 over 2 is X and the Y is 0. And now because we have that, we can put both of that back into this equation over here, y equals to 3x plus c. Where we see y, we put the 0. Where we see x, we put the 3 over 2, and then we end up with the c, and then the equation of the line is complete. So let's just do that. Y equals 3x plus c. So the y equals 3x plus c. We're going to need the point x and y. So remember, we're going to use the point 3 over 2 and 0 because that is the point over there. So put that point in the equation. There's a 0. 3 times 3 over 2. And if you work that out, you'll get 0 equals 9 over 2. And then at the end, take that over, then c is minus 9 over 2. So that, what does it mean? That is this c over here. So this we can take out, and that's going to become minus 9 over 2. And that's the equation of this. Oops, did I remove the line now? That's the equation of this red line, which goes through Q parallel to CD. So I spent some time with this because I just like to explain how I approach things and what I look for. So go through it again, see if you can identify everything I've identified, and maybe also go through more other question papers and just see if you can see something similar. Because in other question papers, they might say or ask or do it differently, but I just try to show you all the angles that can be asked. Usually what they can give, sometimes they will give an equation, then they say work out Q. Here we had to work out the equation. So maybe other times they give you that point of A, then they say work out this blue line AB. Now they have given you AB. So the approach is always to see what intersects with what. If we talk about lines, see maybe what point lie on which lines, because sometimes we have a point Q that lie on the red line and on the blue line. You have this point P that is part of the blue line and the yellow line. You have point B, which is part of the circle and part of the blue line. So if you have things that are part of two equations, then you can already think about simultaneous equations like we did over here. So thank you very much. That was only question 1. I will do more questions on a later stage. Therefore, just subscribe to the YouTube channel, just to be notified when I upload more. Thank you very much. Have a good day. Bye bye.